So, you've decided to stay, you've decided you're not going to breed. There's nothing forcing you to help. Why would you help? The third key decision. Well, firstly, we've gone through arguments about kin selection, but if you're going to gain kin-selected benefits from helping in a group, you've got to actually have an effect. You've got to be able to help your breeders produce more offspring. And you'd think that these correlations would suffice, but actually we know that correlation is not the same as causation. It could just be that in a group with more helpers, the breeders are, groups with more helpers tend to be on better quality territories anyway. And so it could be that you get more offspring in better quality territories and you also get more helpers in better quality territories. It's not that the helpers are having that effect upon the breeders. So you really need an experiment. So there's much fewer cases of proper experimental evidence for helper effects. But one really, the classic one is this Clutton-Brock et al. In meerkats, where they temporarily removed helpers in order to decrease or increase the ratio of helpers to pups. So, or pups per helper. So the more pups each helper is having to feed, they had a control situation where they left a group unmanipulated, but then they decreased the number of pups that each helper was having to feed, and found that the weight gain in the pup was increased. So by effectively increasing the number of helpers per pup, you're increasing their weight gain. And similarly here, when you increase the number of pups per helper, when you reduce the number of helpers per pup, the pup weight gain reduces. So this is experimental evidence for the effect of helpers upon the success of pups. And and we've already met this paper about stuffed badgers. There's, just to reiterate, that there's an absolute ton of evidence that helping behaviour within cooperative groups is directed at kin. So not only can you have an effect as a helper, but also they tend to direct it at kin. So kin-selected benefits is a primary reason why helpers in non-reproductive individuals in groups tend to help. Here's another one. These beautiful, beautiful long-tailed tits. A study by Andy Russell and Ben Hatchwell looked at the percentage of non-reproductive individuals helping within groups, and they found that if kin are present in the group, all of them helped, and if kin are absent in the group, hardly any of them helped. And then within a group that contains both kin and non-kin, the individuals that they help tend to be kin rather than non-kin. Okay, so there's abundant. There are lots and lots of these studies. You'll find lots of them in the literature. There's abundant evidence that helpers prefer relatives to help. Well, a good salient question is also, is helping the best of a bad job? You'll meet that phrase quite a lot. The best of a bad job is if you're forced into a set of bad options, then you want to minimize your disadvantage. A good example of this is eider ducks, where the chicks have to stay in one place while the adults go and feed elsewhere, and effectively it's whoever's left. So that you need an adult there to kind of guard the chicks from predators, and the one that decides to do it is actually the one which didn't get away to feed quick enough. So all of the other adults will bugger off and go and feed, and the one that gets left behind is the one which guards the offspring. And if she abandoned, the offspring would be vulnerable to being eaten by predators. So that's a nice study of the best of a bad job helping. And finally, there's a classic, before we move on to direct benefits, there's this wonderful, wonderful case of a quantitative evaluation of inclusive fitness, kin selection and selfishness completely in balance. In these Tibetan ground tits, I think it's a lovely, lovely study. So here you have a variation among subordinate individuals, whether they help or not. Some individuals choose to help and others don't. And if you look at it from the breeder's point of view, if you get help, so you've got males and females along the bottom here, and the lifetime reproductive success up the y-axis. And if you look at the blue bars, those are the ones that received help, and look at the white bars, those are the ones that never received help. And you can see that the ones that get help have a lot more chicks over time. So there is an effect of there being helpers in this species. But now look at it from the helper's point of view. If you give help, if you never give help, you tend to have about 6 offspring. Whereas if you do give help, you have an average of slightly under 4 offspring. So that constitutes a cost to your direct fitness of helping. But when you calculate how many offspring, the genetic equivalents, as they did with the scrub jays, that you get by helping relatives, by helping the breeders, the indirect component of fitness that you gain, the relatives that you help raise, as in addition to your own chicks, perfectly makes up for the shortfall, the cost that you incurred by deciding to help in the first place. So you have a cost to your direct fitness, which is made up for by the increase in indirect fitness. It's an absolutely lovely study of direct and indirect fitness in balance. So that's a lovely, lovely paper to go and look at.